So we've started learning about how to write Go. We've learned about the fundamentals of Go, how to read and write files, how to build a command line application, and then we converted our application into a web server and learned about HTTP. We created a videos app. Our app stores video data in JSON format. It reads videos and writes videos to file. We have an get endpoint to retrieve all videos, and we have an update endpoint that updates all videos. Now, in the video about HTTP and web servers, our web application stores its video data inside of a file for demo purposes. Now, there are several disadvantages for storing your data in a file. First of all, if we scaled up our application and run it on multiple instances behind a load balancer and a request comes in, it'll only reach one of the instances and update that file, which means the update will be missing on the other instances. So the application is not scalable. If we use the file server and instead pointed all the instances to the same file, and we have multiple requests to update the file at once, we may corrupt that file and then we will lose data. This is where databases come in. Databases allow us to offload all our state, all our data from the application and store it somewhere else, making our application stateless. Databases allow us to control concurrency so we can update multiple records from multiple instances of our application. Now today we're going to be writing some code to store our video data in a database instead of file. And in this example we'll be using Redis. So we'll take a look at some important parts of connecting your Go application to a database. So without further ado, let's go. So if we take a look at my GitHub repo, we have a Golang folder, and in there we have an introduction to Go with a README. And in this README, we talk about the introduction to learning Go. We cover how to run Go in Docker. We talk about all the fundamentals of Go. Then in part 2, we take a look at JSON. So how to read and write JSON data structures and how to read and write files. And then we also take a look at part 3, HTTP, where we build a web server, followed by part 4, where we learn how to write a command line application, and finally part 5, where we're going to connect our application to a Redis database. If we take a look at part 5, we also have a README, and in here we have the introduction to Go, storing data in a Redis database. So be sure to check out the link down below to the source code so you can follow along. So we're going to start by running Redis locally in a Docker container. Now, if you're not familiar with Redis, I have a full series on running Redis in Docker locally, as well as setting up a highly available Redis cluster. In this video, we're going to set up a highly available Redis cluster by running 3 Redis Sentinels and 3 Redis nodes. So you can simply click the link down here to take you to that guide. So in this document, I'm just going to scroll a little bit down, and then what I'm going to do is I'm going to create the Redis network by saying docker network create Redis. That's going to create a Redis network locally I can connect all my containers to, and then I'm going to change directory to the storage Redis clustering. And under my Git repo, we can see I have a storage folder, a Redis folder where all my Redis tutorials is under README. And in this demo, we're going to change directory to the Redis folder to the clustering folder, because this is where I have all my configuration for 3 Redis instances as well as 3 Sentinels. I'm going to run each of these containers individually. So I'm going to say docker run, and I'm going to run Redis 0. So I'm going to start with my first Redis instance, get that up and running. Then I'm going to go ahead and run my second Redis instance. And if I scroll down, I have my third Redis instance over here. I'm going to paste that to the terminal. Now I'm going to say docker ps, and we should have 3 Redis instances running, Redis 0, Redis 1, and Redis 2. Now to form a Redis cluster, we're going to need to run 3 Redis Sentinels, and that's fairly straightforward as well. I've got 3 docker run statements here, and I'm going to run the Sentinel 0. So I'm going to copy paste that to the terminal, then my second docker run command, and my third docker run command, which will run Sentinel 2. So if I run docker ps now, we can see we have a total of 6 containers. We have Redis 0, 1, and 2, and Sentinel 0, 1, and 2. Now remember, if you're unfamiliar with Redis, check out my link down below to my full Redis guide. It'll teach you how to run a single Redis instance, how the configuration works, as well as high availability. So So now that we have a highly available Redis cluster up and running, let's go ahead and create a Docker container as our dev environment so we can start building our application that's going to connect to Redis. Doing all of our work in Docker makes our environment highly portable so we can run it anywhere. So going back to our Golang introduction part 5 Redis folder, we have the README. We've already gone through the basics here of starting up a Redis cluster, and now we're going to set up our Go dev environment in a Docker container. And the first thing we're going to need to do is create this Docker file to define our dev environment. So in the Golang introduction part 5 folder, I'm going to create a new file called Docker file. And in our README, it tells us exactly what to put in that Docker file. So we have a from statement as well as a working directory statement. I'm going to go ahead and copy that and I'm going to paste it into my Docker file. So in this example, we're going to say from Golang 1.15 and we're going to run a tiny Alpine image and we're going to set a target, which is a multi-stage target called dev. This is our dev environment. And in this environment, all we're going to do is set a working directory called work. And we're going to use that directory to mount our source code in. So we don't need to install Go on our machine. Now to build this dev environment container, I'm going to change directory to the Golang introduction part 5 folder, copy that to the terminal, and I'm going to say docker build. I'm going to supply target dev because that's the target we defined in our Docker file, and I'm going to say dot because our source code is in the current directory, and -t. I'm just going to tag this as go. I'm going to copy paste this to the terminal. This will go ahead and build our container image. Now to run the container image, what I'm going to do is say docker run -it -p. I'm going to expose port 80 because our application is a web application that's going to be exposing port 80. And I'm also going to define a volume mount with the V flag. The volume is going to be our current working directory, and I'm going to mount the source code into /work, which is the working directory inside of the container. And I'm going to specify go, which is the container image we've just built. It's the tag up here, followed by sh because I want a shell terminal into the container so I can do my work. So copy paste this to the terminal, and now we're inside of a Go image. I can type go. You can see we have go. So now we have go running inside of Docker. We have our code mounted into the container, so we don't need go installed at all. In part 3 of our series, we've taken a look at how to build an HTTP web service in Go. We're going to need that for this video. So let's quickly summarize it and build our application. The first thing we're going to need to do is define a folder to hold all our source code. So I'm going to create a folder called videos since this is a videos application. So I'm going to run that. That creates a folder on the left here. Then I'm going to change directory into that videos folder, and I'm going to define a new Go module called videos. Inside this folder, it'll create a new Go mod file indicating our module and the version of Go. Now to create our application in the videos folder, I'm going to create a new file called main.go. And then what I'm going to do is define our base logic for our code. So I'm going to copy the snippet and paste it into our main.go. So we have our package main, we've got our dependencies, we're going to be running a web server, so we need net HTTP, we're going to be working with JSON, we're going to be working with files, so we need IOUtil, and we're going to print things to the terminal using FMT. We create our main function, and we define 2 handlers. One is the root path, which is just going to get all the videos, and the other one is a /update path, which handles updates to videos. So 2 endpoints for our web service. And then we're going to listen and serve on port 80. Now, before we go ahead and write these handlers, let's create a separate file that holds our business logic. So what I'm going to do is in this videos folder, I'm going to create a new Go file called videos.go. And as mentioned in the previous videos, we like to split and keep our business logic separate. So we created a videos.go with logic of how to deal with videos. So we're going to create 2 functions here. One is to save videos and the other one is to get videos. So let's start with our dependencies. We're going to define package main. So this videos file is part of package main. We're going to import IOUtil as well as a JSON dependency. Then we want to define what a video looks like. So we're going to define a type struct called video with all its properties. We have ID, title of the video, description, the image URL for the thumbnail, as well as the URL that points to the video itself. Then I'm going to copy the 2 functions from our README. The first one is going to be get videos. So I'm going to copy that, paste it into our videos.go. What this one will do is read a file from the disk called videos.json, read it into a byte array. It'll handle any errors that may occur from reading that file, like if the file does not exist. Then it will use the JSON package to unmarshal, basically converting the bytes of that file into a videos array or slice. It'll again handle any errors that may occur, for example if the file is not in correct JSON format, and then it'll go ahead and return the video slice. So it'll return us a slice or an array of videos. That's the get function. We'll also need a save function. So in my readme I have a save function already put together. So we're going to go ahead to our videos.go and paste that, and the save function takes a slice of videos and saves it back to file, and it does this using the JSON marshal package to convert the slice back to bytes. And then what it does is it will use the IOUtil package to write the bytes back to the videos.json file. So this summarizes how to work with JSON and how to read and write files. Now that our videos logic is ready, we can plug it into our microservice by defining those HTTP handlers. So if we jump back to our main.go, we've supplied two handle functions, one called handle get videos, other one called handle update videos. We need to define those. So let's define those in our main.go. So I'm going to copy the two snippets from our readme. One is called handle get videos. I'm going to go ahead below the main function and paste that one. And what that one will do is it will handle all the requests that comes to our web service on the root path. It will call our get videos function from our videos go file. It will get the videos, convert them to bytes, and write them to the response. So that is the get videos handler. To update the videos, we're going to define the handle update videos function. So I'm going to copy this and paste it in my main.go. And what this one does is it handles the request if it's a post method. So it looks at the request, ensures that its method is post, then it reads the response body, it gets the body back as a byte array, and then what it does is it defines an empty slice of videos, uses the JSON marshal package to convert the body, which is a slice of bytes, into a slice of videos. If there's any errors with the format of that body, we'll get a bad request 400 status code. Other than that, it'll go ahead and save the videos. So it passes the slice of videos into our save videos function. And if any other method is passed, we say 405 method not supported. Now the last thing we need is that videos file. So I'm going to jump back to my HTTP folder in the videos folder, and I'm going to grab my videos.json from that previous series. So I'm going to paste that into my videos folder. So now I have my videos.json. You can see I have two videos defined. Now to build my application, I say go build, press enter, and that's going to produce a videos binary on the left here that I can run. And all I need to do to run it, I say /videos. And that'll run my application. And if I go to the browser and I go into localhost on port 80, you can see I've returned my videos. So this would call the get endpoint on the root path, which is / run our handle get videos handler, which reads the file and returns it to the response. Now we have our lightweight videos microservice with a get endpoint and an update endpoint. And that service will read and write its content to a file. Now let's see what it takes to move our data into Redis and connect our microservice to a Redis database. Now to hook up our application to a Redis instance, there is a Go Redis library on GitHub, which is a very popular library for connecting applications to Redis. It has pretty good documentation. There's a link down here to the documentation. They talk about all the different features, as well as a quick start guide showing you how to define a simple client, pass it a password and an address to your Redis instance, and then how to set records and get records. Now, as you can see here, Redis has a ton of features, but the purpose of this video is to use Redis as a database. So I'm going to show you how to connect to Redis using the library and then read and write our records. Now to get this Redis Go package, we're going to run go get and the path to that package. So I'm going to copy paste this to my terminal, and this will tell Go to go and download that Redis package. If we take a look at the file system, a few things have happened. Take a look at our Go mod file. We can see that we now require an external library. So this is where we manage the version of the library we're going to be pulling down. The Go sum file is also very important because it tracks all the dependencies, not only the dependencies of your application, but the packages you get as well. So this will show you all the packages that the Go Redis library depends on. Now to use that package, we have to go ahead and import it. So we have to define it inside the import statement. So I'm going to grab this bit over here and go to our main.go and add it at the bottom. This is because we want to refer to this Go package in our main.go file. The other thing we want to do is refer to another built-in library called OS, which allows us to read and set environment variables. So to connect to Redis, we're going to need a database address where Redis is located, as well as a port and a password. So we can set these as environment variables and read them from our application. So to do this, it's very simple. When my application starts up, I'm going to go ahead and read environment variables. And there's a few of them that I want to read. So I'm going to copy paste this into my main function. So here we have the address of where the Redis sentinels are located, the name of the master we're looking for, and the password to authenticate. Now, a lot of people get confused with Redis and high availability. I always get the question of how do I connect to my master when the master is down? Remember, when you run Redis in high availability mode, you need a library that has Sentinel support. Sentinel instances give you the service discovery and leader election for the master nodes. So if the Redis master nodes die, we're able to query the sentinels to get a new master address. In our demo, we're running 3 sentinels to get high availability. This means if there's a sentinel down, we can query any other sentinel. If all the sentinels are down, then our Redis cluster is down. The sentinel will give us the address of the master so we can establish a connection with the master and start reading and writing records. If that master becomes unavailable, we'll query the sentinel and get an address for the new master and establish a new connection. So this environment variable called Redis sentinels is going to hold the addresses of the sentinels. We have 3, so we're going to have 3 URLs in that environment variable. Now to connect to Redis, we also have to import a standard library called context, and the context can be used to control timeouts and deadlines for our application. We're not going to use that yet, so we're going to set an empty context. So what I'm going to do is create an empty context for now by saying var ctx equals context.background, and I'm going to instantiate a new object that I want to use called the Redis client by saying var Redis client, and the type is coming from the Redis package that we've imported at the top here. So it's called Redis, and it is the client object. The client will help us make a connection to the sentinels and to our Redis instances to perform Redis operations. Now what I'm going to do is I'm going to take this context variable as well as the Redis client, and I'm going to cut and move it outside of my main function so it becomes a global variable. This means we can use this Redis client anywhere in our application as well as in our videos.go file to talk to Redis. So once you have that client as a global variable, there's multiple ways of configuring the client and creating a connection with Redis. If we go to the GitHub repo for the documentation and we click on documentation, there's really good documentation on how to get started. You can see here, similar to how we've done it, we created a context, and here's how you set up a client. So you create this client calling that Redis library, which you've imported at the top here, and you say, I want a new client, and you pass the options like the address to your Redis instance as well as a password. And then you can immediately start using it by setting records and getting records. But this example only connects to a single Redis instance, like a single master. What if you have 3 masters and 1 master is down? This is where the sentinels come in. So instead of using the simple example, I'm going to head over to the Getting Started guide, the documentation, and I'm going to select Redis Sentinel. This will take us to the Redis Sentinel support where we can create a new client called a new failover client. And this is exactly the same as the Redis client. The only difference is it gives you Sentinel support. So instead of passing in the master address, we pass in the list of Sentinel addresses. That means that every time we make a connection to the master and that master is down, the library will automatically give us the address of the new master. So let's take a look at what that looks like. So the first thing I'm going to have to do is get all the Sentinel addresses. So we get that from an environment variable, and this is going to be a comma delimited string. So what I'm going to need to do is import a new built-in library called strings. So I'm going to import that, and because I read my variables here as comma delimited, I'm going to go ahead and split them by comma and then pass it to the client. So to do that, once I've read all the environment variables, I'm going to say sentinel addresses, which is a new variable, and I'm going to say strings.split and split the environment variable that we're passing in by comma. So this will create a new slice holding all the sentinel addresses. And then I'm going to copy this block, which I got from the documentation I just showed earlier. We're going to paste it here in our main.go, and this is going to establish a new client. So I create a new variable called RDB. You can call it anything you like. I then call the Redis library, and I say I want a new failover client. And then I pass in some options, calling redis.failover options. And here you can pass in various options based on the configuration of Redis. So I say, here's my master name, and the master name comes from an environment variable. This is not an address. This is simply an alias of the master. And here I pass in the sentinel addresses. That is the array or slice of addresses of the sentinels coming from environment variable. And another environment variable I'm passing in is the Redis password. So I'm setting that as well. And then by default, I want to access database 0, which is the only database as part of this cluster. So now I've set up my Redis client. I want to assign it to my global variable. So I'm going to say Redis client, which is my global variable, and assign that RDB to it. So I'm just going to do that. That will now populate our Redis client global variable that we can use anywhere. And just to test whether all of this works, before I continue and write a lot of code, I want to just call a ping command. So I'm going to say rdb.ping, and I'll pass in the context. This will make a ping request to the Redis instance to make sure everything is working as expected. So now that our application can connect to Redis, we're going to have to restart our Docker container so that we can pass those environment variables into the container. That'll allow it to connect to Redis. The other important bit is we have to make sure our container runs on the same network as the Redis instances so that they can talk. So remember, we have set up a Redis network when we started running all the Redis containers. So what I'm going to do now is I'm just going to exit out of this container we're running, and we're going to have to rerun our container. We say docker run -it. We pass in the port as we did before because we're running a web service, so we have to expose our port, which is 80. I then say --net Redis. So I pass in the network I want the container to run on, which is the Redis network we created earlier when we spun up all our Redis containers. This will ensure that our container can actually talk to the Redis instances. Then what I'm going to do is expose the environment variables we set earlier. And notice here I have the Redis sentinels I created earlier. This is a comma delimited list of all the sentinels. And if I do docker ps, you can see the names of my sentinels, sentinel 0, 1, and 2. So those are the DNS names of the sentinels. So I set them, and they're listening on port 5000. I then pass in the master name, and it's just called my master. And then I pass in the password. Then I'm going to mount my code as I did before, call the same container name, and get sh access. So I'm going to go ahead and grab this, and I'm going to paste it to the terminal. Now we're inside of our Go container. I can do ls, my code is there and everything. I can change directory to my videos folder. I can say go build, and this will go ahead and make sure that the dependencies are there, produce a binary on the left, which I can then run by saying /videos. I run that, and notice we can see here that it's connecting to Redis. It's discovered the sentinel, and it's discovered the master, and it has the API address of where that master is, so it can talk to it. So now that our application is connecting to Redis, let's go ahead and update all our business functions for our videos application to read the data from Redis instead of a file, and also to write it to Redis instead of a file. So the easiest place to start is the save videos function, since we can't get videos from Redis because there is no videos. So instead of saving the data to the file, let's change this function to write to Redis. So to save videos, our save video function gets a slice of videos. It then converts those videos to a byte array or slice of bytes, which it writes to file. Now, instead of writing to file, what we're going to do is we're going to remove this line that we have here, and instead of writing to file, we can write it to Redis. So this is very simple. The way I do this is I say error equals, because this function will possibly return an error. I say Redis client.set. I pass in the context, which is our global variable, the empty context we created. I pass in the video ID because that is the key that I want to use to store my video in. It's a unique ID used that I can use for searching to find that video. So I pass in the key of the document and then the contents of the document, which is going to be our bytes or our slice of bytes. And then the same as writing to file, I get an error back and I just make sure I handle that error. Now what I'm going to do is, because I want to write individual videos to Redis, our current function is save videos, which takes in a slice of videos instead. So what I want to do is I want to change this function to save video, so it only saves an individual video. That means it'll no longer take in a slice of video, so it takes in a single video object, gets the bytes of that video struct, and writes it to Redis, taking the video.id as a key. So we want to be writing one record per video. Now, since we have an endpoint that updates all videos, what we're going to do is create another function called save videos, which takes in the slice of bytes like we had earlier, and then iterates them using the simple for loop that we learned about in our introduction. So we're going to loop through all the slices of videos and then save them one by one. So very simple. To recap, we have a save video that takes in a single video, converts it to bytes, writes it to Redis using the ID as a key, and then we have a save videos function which takes in a slice or an array or list of videos, loops them and writes them one by one to Redis. Now we want to do a similar thing for get videos. So we currently have a get videos function. We now have save video and save videos. So what I'm going to do is define a new function called get video, which gets a single video by ID. So in my README I have this code block that I can use. I'm going to paste it below my get videos function, and notice this one is called get video. It takes in an ID of type string. This is the video ID, and it returns a video struct that we have defined up here. Now the way it does that is it simply goes Redis client.get. So it calls the get function of the Redis client, the global variable that we've set earlier. We pass in the context, we pass in the ID of the video that we got from the parameter on this function, and we call the result function. This will give us the result of that get. We then handle it by handling the error that comes back. So we say if the error is not null, then panic. This allows us to handle if there's a failure talking to Redis. And one scenario we do have to handle is trying to get a record that doesn't exist. If the record doesn't exist, we'll get an error called redis.null. So we need to make sure we don't get a redis.null error that comes back. And if it doesn't come back as redis.null, we can simply go and access the value. We can then call the popular library we used before by saying json.unmarshal, and we can convert this bytes. I'm passing the value here, converting it to a slice of bytes, and the value is the result we got from our get call. And then we're going to convert that to a video struct by calling the json unmarshal function. And then what we're going to do is return the video. So to recap, all this does is takes in an ID, makes a call to Redis using that ID, calls the get function to get the record, handles any errors that may come back, then double checks to ensure the record is not null, and then unmarshals it to change the record from a byte array to a video struct, and then returns that video to the caller. So that's our get video function for getting a single record from Redis. Now what we have to do is update our get videos to read all the videos from Redis. Now currently our get videos function takes in no input and returns a slice of videos. So we're going to maintain that, but we're not going to read from file anymore. So I'm going to remove this line, and what we're going to do is we're going to return all the keys from Redis, because in Redis we store objects as key value pairs, the key being our video ID and the value being our video byte array. So I'm going to say Redis client.keys by getting all the keys. So I say star, passing in star will tell the library to get all the keys back. And then similarly I say I want the result out of that, which is going to be populated into our keys variable over here. Then again I handle any errors that may occur, and then I'm going to iterate those keys. So what I'm going to do here is I'm going to say for each of the key in the range of keys, and for each of those keys I'm going to call the get video function we created earlier by passing in the key. The key is the video ID, so we pass in the video ID to our get video function that will return the video. Then we append it to this array we defined here, the empty array, by calling the built-in Go append function, passing in our array and the single video. So this will loop all the records from Redis, get them all, populate them in this videos array, and then we can remove this line since we're not talking to file anymore, and we can simply say return the videos. Now to get this to work, all we need to do is in our videos.go at the top in the import function, we're going to need to also refer to the Redis library. And then also we're not using the IOUtil anymore since we're not talking to any files. We can go ahead and remove that import. Now to test this, I can go ahead and run go build. So I say go build. We can see that has passed with no errors, and we have our binary on the left hand side. I can go ahead and run this by saying /videos, and we're now connected to Redis. So let's go ahead and test this now to see if we can access our values. Now we know Redis is going to be empty, so we have to populate it. So let's go ahead and use Postman to post some JSON data to our service. So what I have here is a Postman application, so I can post web requests with ease. So in Postman, I'm going to define a URL I want to post to, which is going to be http localhost port 80/update, and it's going to be a post method. And what I'm going to do is I'm going to follow my readme instruction. I'm going to grab the array of videos. You can see here I have a JSON array with 2 videos that I want to add. And if I come to Postman and I click on the body, I can pass in the array here. So here I paste in my JSON data and I click send. And notice we get a status 200 OK. So that is the status code that our web server returned. So now these 2 videos are stored inside Redis and we can access it through our microservice. If I go back to the browser on localhost, I can refresh it and see that I get the same JSON content back. That means our update endpoint and our get endpoint is working. Now for concurrency, it's not ideal to have an endpoint to update all our videos, because if we have multiple clients making a call to our microservice, updating all our videos at once, they may corrupt our records and they may override each other. So let's go ahead and make some improvements to be able to get and store videos by ID, because most of our clients will want to update single videos at a time. So we already have all the functions in our videos.go. If we collapse these, we can see we have a function to get all videos, we have a function to get a single video, we have a function to save all videos in a bulk, and we have a function to save a single video by ID. So all we need to do is update our handlers. So if we go to our main.go, we'll want to go ahead and improve our handle get videos. So we can get a video by ID. So what we're going to do is access the request object here by saying ID equals, and we're going to access an ID by query string. We're going to say request.url.query, call the query function, which will return a dictionary of key value pairs of the query string. So this allows us to get a query string called ID. So the user can pass an ID of a video over the get endpoint and return a single video. Now this query will also return a boolean to say whether it's successful or not. So what we can do is if it's okay, if it's successful, that means that someone did pass an ID over the query string. We can then go ahead and use it. So what I can then do is inside that if block, I can say if it's okay, the video ID is equal to the first instance of that ID. So this will get the video ID from the query string and store it inside a variable called video ID. And then I'm going to call my get video function. I'll say get video by ID and return that video. Now there's 2 scenarios I want to handle here. If we return redis.null, meaning there is no value in Redis, the ID will come back empty. So this video will not have an ID. So in case there is no record in Redis, I'm going to say if video ID is blank, that means the video is not found or it's empty. I'm going to return a header 404, which is status not found. And I'm going to write a blank byte array back to the response and return. So this is handling a simple 404 where a video does not exist. Otherwise, if the video does exist, what I'm going to do is convert that video into bytes using the json.marshal function. I'm going to handle any errors that may occur, and I'm going to write that bytes back to the response. And once I've written written the bytes to the response, I'm just simply going to return out of this function. So this is a simple if statement to check if the client passed in an ID as a query string, and then we'll go ahead and access that single video and return it. Otherwise, if the ID was not passed in, we'll fall back to the original logic of returning all the videos. Now we're going to make a similar change to the handle update videos. So in here, we check if the method is equal to post, and then we go ahead and read the entire body. Now what we want to do is also check the query string. So once we've read the body, we want to check the query string to see if there's an ID available. And if there is an ID, we'll do a similar if statement to check if there's an ID and it's all okay. And what we want to do is if it's an ID, we'll know it's going to be a single video that the customer wants to update. So we can create a new variable called video, which is of type video. We can then unmarshal that body, which is going to be JSON content of a single video. So we unmarshal it into our video struct. And then we're going to handle any errors that may occur. So if the error is not null, we can return a 400 back to the client saying bad request. That means we can't parse that JSON body. And if there's no error, we simply say save video. So we call our save video function, pass in that video, which will go ahead and save it to Redis. And then we can simply say return to break out of this function. So that is the simple if statement block to check the query string if there's an ID. If there is an ID, just go ahead and parse and save that single video to Redis and return. And if there's no ID, we'll go ahead and define an empty slice. We'll unmarshal the request body into a slice of videos. If there's any parsing issues, again, we'll return a 400 with bad request. And then we'll go ahead and save the slice of videos. So this will fall back to the original logic of saving all the videos. So to make sure that builds, I can say go build, and we can see there's no error. So let's go ahead and update our Docker file so we can build a runtime image. And this is very simple. Currently, we only have our dev environment. So we'll want to go ahead and extend this by being able to build it inside of Docker. So I'm going to create a new multi-stage build with the same version of Go as build. I'm going to set my working directory to /videos because that's where our source code is. I'm going to copy the contents of our local videos folder into the container on /videos. And then I'm going to run go build to produce a binary called videos that we can run. Then to make a production layer in multi-stage, I'm going to say from Alpine as runtime. So the runtime won't have any Go SDK. And then I'm simply going to say copy from the build layer, copy our videos binary into the root path. So just say /. And then to start up this Docker image, all I'm going to say is command and start up our binary. I can now go ahead and exit out of my container over here. We can go ahead and build this by saying docker build, and this time I'm going to tag it as videos. So that's gone ahead and built, and this time I can run my container without mounting a file. So now our application is stateless because it doesn't store any data within itself, and it doesn't have the drawbacks of writing to file. So I'm going to say docker run -it, expose port 80, run it on the Redis network, pass in the Sentinel addresses as well as our master name and our password. And this time I'm just going to call my videos container because that's how we built it. I go ahead and run my container. And if I go to the browser, I can see my videos are still there. So all my state is now stored in Redis. Now, if you're new to Redis, be sure to check out my Redis guide down below. And hopefully this video helped you understand the fundamentals of talking to a database from a Go application and how to connect to Redis. Now let me know down in the comments below what sort of videos you'd like to see in the future. And if you liked the video, be sure to hit the like button and subscribe and hit the bell. And if you'd like to support the channel even further, be sure to check the Patreon link down below or become a YouTube member. And as always, thanks for watching, and until next time, peace.